Hi guys, today we're also doing minimum consecutive cards to pick up. So you're given an integer array cards where cards at I represents the value of the ith card. A pair of cards are matching if the cards have the same value, and they want us to return the minimum number of consecutive cards you have to pick up to have a pair of matching cards among the picked cards. If it's impossible, then return -1. So we're given two examples down here, one where we do have one and one where we don't. So in this one we return 4 because we have this possibility where we have the matching 3s and this has 4 cards in here, or this possibility where we have the matching 4s and that also has a length of 4 or 4 elements in here. So, and this one has we return -1 because there's no duplicates, so there's no possibility of having any matching cards. So I already put the examples over here with their indices labeled. So as we're gonna iterate through cards, and we want to map each card to its index as we go through, and keep track of a minimum. So I'll show you what that would look like. So we can first initialize our minimum to max value, and then we're gonna want a map. And then, okay, so that's empty. And then, so as we iterate through cards, we're going to check if we have a 3 in our map, and we do not. So we're going to add the 3 and map it to 0. So basically, if we do not have this card, we're going to add that card with its index. If we do have that card, we're going to update the minimum, because that means we found a duplicate, right? We're going to update the minimum and update the index in the map to the new index, so that if we find any more duplicates down the road, we can just use this one. We don't really care about the previous one anymore, because that would just make it longer, right? So, okay, we continue along 4. We do not have a 4, so we map it to 1. We do not have a 2, so we map that to 2. And we do have a 3, so we update our minimum by checking this index minus our last seen index plus 1. So that's 3 minus 0 plus 1 is 4, and 4 is less than max value, so we update this to 4. And then we also have to update this to our new index, which is 3. So then we continue. We do have a 4, so we're going to do the same process. 4 minus 1, because 1 is here, is 3, and then 3 plus 1 is 4, so that just stays 4, but then we still need to update this to 4. And then we run into 7. We do not have a 7, so we're going to add 7 and map that to 5. And then now we've reached the end of our list. So we just return our minimum, which is 4. So in this case, so we can also make our minimum max value. And then our map is empty right now. So as we loop through cards here, we do not have a 1, so we're going to map 1 to 0. We do not have a 0, so we map 0 to 1. We do not have a 5, so we map 5 to 2. And we do not have a 3, so we map 3 to 3. And then we've run into the end of our array. So since we found nothing, we're going to update our minimum to -1, because we don't want to return max value. And we're just going to return -1. Okay, so now we can start building out our actual algorithm. So I'm going to initialize a minimum to max value, like we said, and then we're going to initialize our map. Okay, and then we need to loop through our cards. So just a regular loop. Okay, and then if we do not have this card in our map already, we're going to add it. So and we're going to map it to the index, which would be I. And if we do have it, then we are going to update our minimum of between our current minimum and the index, our current index, which is I, minus the previous index, which is going to be like if here it would be 0 if we're at this 3, right? So map, so we need to get that out of our map. So get okay, so cards at, yeah, so we're going to get this value, which is 0, and then we're going to plus 1 because arrays are 0 index, so it's basically just to like offset the 0 indexing. So then we do 3 minus 0 plus 1 is 4. Okay, and then we need to update this value to our current index. So we're going to do that. So map.put, and then we're going to update cards at I, which is our current card, with I, which is our current index. So we're going to do that for the entire cards array. And then once we reach the end, so as you remember in this one, where if we did not find that value, then minimum is still going to be max value. And if that's the case, then we're just going to set minimum to -1. And then we're going to return minimum. Because otherwise we did find something and then we're just going to return that. So let's see. Okay, so our time complexity is going to be O of n, where n is the number of elements in cards. So if we scroll down here, we can see that we just have one loop here, and this loop is iterating through cards n times. So that's how we get this, and the rest of this is just constant, so we don't care about that. And then our space complexity is also O of n, and same thing here. Because if we scroll down, we just have this hash map. And worst case, if every single card is unique here, as you can see in this example, we store every single card with its index once. And so there's going to be a total of n elements in maps, worst case, right? If every single element is unique. If not, like, it's going to be better, right? Because here we had 5 cards, but we only stored 4 because there's 4 unique elements. So basically it's just the number of unique elements that we have, but worst case it's going to be n. So that's it for this problem. Thank you guys for watching, and let me know what problem I should do next.